Hi again, everybody. Today we're going to learn about standard deviation. Standard deviation is one of those hot button topics that a lot of people talk about when they talk about statistics, is because it gives you a lot of information. Also, when a teacher says that they grade on a curve, this is what they mean, is that they're making everything fit into a bell curve given specific standard deviation. So let's find out what this is about. First, let's go over our vocab. A measure of variance describes how the data in a data set is spread out. So it just explains to us how spread out is our data, where is it clustered together. Variance and standard deviation are measures showing how much data values deviate from the mean. So what we're going to do is first we're going to find the mean, and then we're going to talk about how you find your deviation from the mean to calculate it, and then how everything fits within that range. Alright, so we're going to first talk about how you find variance and standard deviation. So this is kind of a lengthy process. There's an equation at the end, but if you just remember the process, you're going to be okay. Alright, so first thing you want to do is find the mean of the value sets of your data. So remember to find the mean, we take them all up, add them together, divide them by however many we added together. Next thing you're going to do is you're going to take the difference. You're going to take every value set and you're going to subtract the mean from those. You're going to do that for every single number that you're given and find the difference. Then you're going to take and square all the differences, everything that you just subtracted, square them all. And then you're going to find the average of the squares by adding them all up together, dividing by however many you added together. And then you're going to take the square root of the variance, and then this is how you find standard deviation. So here's your formula. It's really long. It just says that you take the square root of the sum of the values minus the mean squared divided by the total number of terms. So you take the average of subtracting the average from all the numbers and squaring them and stuff, and then take the square root at the end. So it's not a difficult process. It's kind of lengthy. Some people get really confused on the formula, so if the formula doesn't help you, then just go ahead and follow the process. Alright, so first thing we're going to do is we're going to find the mean, the variance, and the standard deviation of these values. So I have 6.9, 8.7, 7.6, 4.8, and 9.0. So the first thing we want to do is find the mean. So remember, in order to find the mean, we're going to take our set of numbers, we're going to add them all together, and then we're going to divide by however many numbers there are. Well, in this case, there are 5 numbers. So let's go ahead and add them together. So I got 37 when I add them all together. Take and divide that by 5, and you should get 7.4. Okay, so 7.4 is the mean of this data set. Now what we're going to do next is we're going to take all of the numbers, 6.9, 8.7, 7.6, 4.8, 9.0, and we're going to subtract our mean. But we're always going to have a positive number because it's going to be squared here in a second. So don't worry too much about negatives. Okay, 6.9 minus 7.4 is negative 0.5. 8.7 minus 7.4 is 1.3. 7.6 minus 7.4 is 0.2. 4.8 minus 7.4 is negative 2.6. 9 minus 7.4 is 1.6. Once we find the difference of all of these, then we take and square them all. Remember, after this step, they should all be positive numbers. All positive numbers. So 0.5 squared is 0.25. 1.3 squared is 1.69. 0.2 squared is 0.04. 2.6 squared is 6.76, and 1.6 squared is 2.56. Okay, so we found the average, found the mean, subtracted the difference of the mean from all the data values, squared that difference, and now what we're going to do is we're going to take the average of these. So we're going to add them all up together, 0.25 plus 1.69 plus 0.04 plus 6.76 plus 2.56. I get 11.3. Now what we're going to do from here, we're going to find the average again. So 11.3 divided by those 5 numbers is 2.26. And then our last step, we're going to take the square root. So you should get 1.50 or 1.5. All right, so we found our mean, our variance, and our standard deviation. Woo, okay. So the mean is the 7.4. Our variance is all the numbers that we added together after we subtracted the mean, squared them. So added all them together, that's your variance. And then your standard deviation is your 1.5 at the end. So these are the 3 numbers that you're going to be looking for. The mean, add them all up, divide by how many they are. The variance, by taking each of the data values, subtracting the mean, then squaring them, getting all positive numbers, adding them together. That's your variance. And then your standard deviation is when you take your variance, divide, and then take the square root. All right, so not too shabby. It's kind of lengthy, a lot of math. You need to be really careful. Make sure you're always getting positive numbers in this column. If you get negative numbers, you did something wrong. Go back and check. Make sure when you squared the negative, or just don't include the negatives at all, because it doesn't matter after you subtract them. They should all be positive numbers after you square them. Okay, so moving on. Okay, I want you to go ahead and try this one by yourself. What are the mean, the variance, and the standard deviation of these values? Go ahead and pause the video, give it a try, and then I want you to compare with your table mate. I will also put the answer up here in just a minute, but first I want you to try it by yourself. So go ahead and pause. Alright, so here I found the mean. I added the numbers up together, divide by 6, and then I found the variance. I took the mean, subtracted it from all those numbers, squared them all, added them together, and then to find the deviation, divide the 690 by 6, and then take the square root of it. So hopefully that's what you got compared with your table mate. If you didn't get this and your table mate did, maybe you should see what you did wrong. Also, if you both got it wrong, go through and check it again. Alright, moving on. Next we're going to talk about how to use a calculator to find standard deviation, because there is kind of a shortcut. So this table displays the number of U.S. hurricane strikes by decade from years 1851 to 2000. What are the mean and standard deviation for this data set? So as you can see, they have the decades listed from 1 through 15, and then how many strikes that there are. So what I'm going to do is I'm going to try to pull up my calculator here. Okay, so if you have a TI, then this will walk you through how to do it. If you don't, if you have like a Casio, we've done how to do data before, so hopefully you're able to do it if you remember, and then you can find the different calc features. So what we're going to do first is we're going to go to our stats, and we're going to edit our stat list. So in our list 1, we're not going to put the decade because decades are increasing by 1. We're just going to put how many strikes there are. So I'm going to put 19, and then 15, 20, 22, 21, 18, 21, 13, 19, 24, 17, 14, 12, 15, and 14. Okay, and it should say, now it says I'm on row number 16, which is good because I had 15 data sets, so I didn't forget any of them. All right, now we're going to go back to our stat, and we're going to go over to calculate, and we're going to do the one var stats. So it's going to give us one variable statistics. Just go ahead and hit enter, and it's going to ask you what list you want. Well, I want to do list 1. Okay, up here, this first line right here, oh, you can't see it. I'm going to use my cursor. Okay, so this first line right here, that's 17.6 with the X with the line over it, that's our mean. And then it gives us the sum and then our deviation is this one here at the bottom. So when you do it this way, you can only find the mean and then your standard deviation. So our mean in this case is 17.6 and our standard deviation is 3.51. There you go. So there's a way to do it on your calculator to check and make sure you're getting the right answers, but don't use it for all of them because I want to be able to see your work. Lovely. Okay, so we're going to go back to this, and we did that. Okay, now, if you've ever seen the bell curve before, or if you haven't seen the bell curve, this is what teachers mean when they say they're grading on a curve, is they're forcing the data to follow this pattern so that you have right here, you have the majority of your data. That accounts for, let's see, that's 68% of your data falls within the C range. And then you have 14B and 14D. And then you only have 2% A, but you also have 2% F. So when a teacher says they're grading on a curve, what they're doing is making the data fit all into this shape right here. Okay. All right, so what we're going to do is we're going to take that same data that we had before, and we're going to talk about this bell curve and what that means. Okay, so I'm going to draw this curve again. And down the middle, this is our mean. Remember, our mean was 17.6. Is that right? Oh, I lost it. Hold on a second. Okay, yes, our mean was 17.6, and then our deviations were 3.5. So that means to go from one line on the graph to the next line on the graph, you're going to go a difference of 3.5. So to go in the positive direction, I'm going to add 3.5 to get to every deviation. But then to go backwards, I'm going to subtract 3.5. So then to find these values, I'm just going to use my calculator and do, there we go. 17.6 plus 3.5. So our first deviation is 21.1. Then add another 3.5 and you get 24.6. And then add another 3.5 and you get 28.1. Okay, then to work backwards, I'm going to take that 17.6. I'm going to subtract 3.5. And I get 14.1. Subtract 3.5. I get 10.6. And then subtract 3.5, and I get 7.1. So the question asks us to find within how many standard deviations from the mean do the values fall. So let's see, we have 19 is right here within one standard deviation above the mean. 15 would be one standard deviation below the mean. 20 would be one above. 22 would be 2 above because it's bigger than 21.1. 21 would be 1 above. 18 is 1 above. 21 is 1 above. 13 would be down here between 10.6 and 14.1. So that's 2 standard deviations below the mean because you go 2 to the left. 19 is 1 above. 24 is 2 above. 17 would be 1 below because it's less than 17.6. 14 is 2 below. 12 is 2 below. 15 is 1 below. And 14 is 2 below. So our answer to that question would be within how many standard deviations of the mean does the data fall? Well, we go 2 standard deviations above and we go 2 standard deviations below. So we would say within 2 standard deviations of the mean. Okay, so I want you to work on this one. You could do it in your calculator. Remember, you only need to use the strikes. You don't need to use the decades. Just use the strikes to put into your list. I want you to find the answers to these questions, compare them with your table mate, and then when you guys are done, you can work on your homework. All right, I will see you later.